So I will spend a little bit of time going over evolution. Thank you for watching, and remember, if you have any questions, make sure to post them in the comments so that your group can try to answer them. Otherwise, just shoot me an email and I'll get back to you as soon as I can about it. So let's start out by looking at how evolution happens. For starters, we need to understand that evolution is a theory. And when we talk about a theory, there's a couple of pieces of confusion that people have. So remember that anytime we think about a theory, we're thinking about something that is well supported with evidence, as well as something that is explaining some other phenomenon. And Darwin described natural selection, but we're also going to take a minute and talk about genetic drift. So really two mechanisms of how evolution happens: natural selection and genetic drift. Let's take a second and look at the historical considerations. So the past understanding of evolution and how modern evolutionary theory has come to be. We can start out by looking at the Greek philosopher Aristotle, and Aristotle came up with this idea of scala naturae, which basically said that all living things were on a scale or a ladder from most simple down at the bottom. So things like rats would have been one of the smallest things that they thought of, like insects and rats, and then eventually working your way up to the top, you had people and then the gods. Carolus Linnaeus also believed that all living things were kind of on a scale, but more so that they were nested group within group. And he came up with this idea of binomial nomenclature. So we could divide things into the largest kingdoms, which at the time were believed to be plants and animals. Since Carolus Linnaeus's time, we've also come to recognize fungi, which are not related to plants any more than they are to animals, and as well as the prokaryotic species, so different types of bacteria, which are actually placed in a different domain, kind of a bigger category than even kingdom. And kingdoms are made up of a whole bunch of phyla. Phyla are made up of a whole bunch of different classes, and so forth down the line until you get to this very specific way of looking at organisms. The genus is kind of a group of different species, and when we give an organism binomial nomenclature, what that really means is that we're naming them with two names, the genus first and then the species. So for example, if we're looking at Homo sapien, that means that our genus is Homo and our species is Homo sapien. Two names, first the genus and then the specific epithet that makes up the species name. And so when you look at other things like Canis, that is a genus, and Canis means dog. Canis familiaris would be the house pet dog, whereas Canis, Canis, oh boy, lupus, there it is, would be the wolf. So essentially, groups that are more similar are in lower related taxa, whereas groups that are more different would be in the higher taxa. But an important thing that Linnaeus believed was that God had created them all in this nested fashion, and that they were fixed in time. So you should be fairly familiar with Charles Darwin. He's considered the father of evolutionary thought, but he actually drew his ideas from a number of different scientists, as well as other facts that had already been understood, and then kind of his own journey. So let's start by looking at geology. So Cuvier was one of the first geologists to kind of start understanding how different processes on Earth worked, and he believed that various different strata in the Earth's layers represented cataclysmic events that had happened, and each of these would have been associated with some kind of extinction. So he believed that when a species had been trapped and some kind of catastrophic incident had happened, that would have led to their extinction. But then the new species that were on top, so for example, we might have like, a very simple fossil down here of some kind of organism, and then you could see that it had gotten more complex over time. Well, Cuvier would have said that this guy down here became extinct, and then this guy right here must have migrated from another area. So he didn't really see the layers of Earth as being a continuation of species changing over time, but instead said that his viewpoint supported the Old Testament and species were fixed and not changing. Hutton and Lyell were two more geologists that came after Cuvier, and they realized that the same processes that happened a long time ago were still at play, which meant that processes like cutting through into canyons via a river, that didn't even make sense, but that's okay. When a river cuts through a canyon, that isn't necessarily something that just happened, right? This would have taken a long time for these layers to have been exposed one at a time. And so this led to the idea of what is called uniformitarianism, basically saying the processes have continued on Earth, and that went in the direct face of Cuvier's catastrophism. That also meant that for processes like a river digging its way into rock to have occurred, Earth had to be way older than previously understood, right? So, according to the Old Testament and the lineages in the Old Testament, most people in Hutton and Lyell's time believed that Earth was only about 6,000 years old, and they came to the determination that it was closer to 30 million. They're closer, but still a couple of orders of magnitude off. Thomas Malthus was another scientist. He looked at social interactions and how populations of humans in cities were growing, and realized that in London, as the population got bigger and bigger and bigger, something would kind of cap off that population. So as the population grew, death would increase, causing the population to go down, essentially saying that when overpopulation happened, things like war and famine and other density-dependent factors would come into play to bring that population back down. Now, Malthus was talking about the human population, but Darwin was going to kind of take that idea and run with it in terms of animal and plant populations as well. Okay, so another well-understood concept in Darwin's time. Most people said species don't change over time unless they were caused by human interaction. So artificial selection is well understood in Darwin's time. Basically, you breed different animals and you pick a desired trait and you breed them based on that. So we start here with teosinte, which is an ancient corn. As the variation in the corn crops grew, then you would pick the corn that had the most fleshy kernels, and then you would plant only those ones, cultivate them, and eventually over time you ended up with what is now modern corn with like giant kernels. The same philosophy was well understood in pigeons of Darwin's times. Apparently it was kind of like a cool thing to make weird looking pigeons, like this guy, like what? Anyway, as well as in farming, you would take a wild cow. You'd pick the one that was either had the highest milk production or was just ginormous, and that would be the one that you'd breed. So eventually, over time, humans understood that we could cause species to change. But again, it was kind of believed that it only happened as a result of artificial selection or breeding because of human influence, and that it wouldn't have occurred in nature. Now, you guys read a little bit about Lamarck over the summer. Remember, he had the idea of use and disuse. So you use something, it would appear or continue in the lineage. If you didn't use it, it would like, die off and not exist anymore. So for example, there is the example of flies. So you take a fly and you cut off its wings. That makes a walk. Very sad little fly, right? And he makes little baby flies. And according to Lamarck, because the daddy fly, this guy right here, never was able to use his wings, the baby flies should be born without wings. But in fact, after going through the maggot stage, as all flies do, they developed wings. And so they took these again and continued to breed, taking off the wings each time as soon as they had developed. And after generations, the fact remained that flies made wings. So Lamarck was kind of wrongish, but we'll talk later in the semester about why maybe he had some ideas that were right. So if you ever hear use and disuse or acquired traits, remember to link them to Lamarck. Okay, so Darwin's taking a lot of different ideas from other scientists, but he's also doing a voyage where he discovers quite a few things, and he's starting to make some connection. Now, the HMS Beagle was the ship that he went on, and he was really not there to collect data or anything like that. The ship was going around the world, and in particular, they wanted to chart out the coastline of South America. So Darwin was allowed to join as the naturalist on the ship, but also to be the captain's company. And on his voyage, what he noticed were really three different things. So when you had organisms living in similar habitats, the organisms seemed similar in a way because they would have become well suited to that environment. So if you're looking at like a desert, it doesn't matter what continent you're looking at, you're going to have shrubs that are low lying, that are kind of spiky and really good at conserving water. It didn't matter if it was in Africa or South America or in Australia, the same facts held true. And even within like the same environment, you would end up with organisms that differed slightly. So this is where you're looking at things like Darwin's finches, which in one localized area still had different beak shapes. And then finally, as you look at the fossil record in those different strata of Earth's layers, he saw the same thing Cuvier did, only made the connection that over time they seemed to change. So he looked at like really big armadillos and realized that they're just bigger versions of extant. Let's write that word so you remember it. Extant, which is the opposite of extinct. So extant species alive today had some familiarity with extinct fossil records of the past. So he's starting to put these pieces together. Organisms are well suited for their particular environment. There's similarities among organisms that appear different, but also organisms have vast differences, and most people knew this. This wasn't a surprise, except for Darwin finally started to put these ideas together in a way that explained how species might change over time. And, Darwin applied this idea of evolution to why all of these facts would be true. So when we think about evolution, think of it as a pattern, right? The patterns that Darwin noticed, as well as the process and explanation that explains the patterns that he observed. And so Darwin finally came up with his idea of natural selection in the mid 1850s or so. And so let's take a look at that. Essentially, natural selection was described by Darwin as descent with modification. I'm going to break this definition down because I think it's a really strong definition. So, Darwin described descent with modification as changes to populations that were based on their interactions with the environment, allowing those with adaptations to have increased fitness. And so we've got a couple of definitions that we need to be familiar with down here. Populations are a group of individuals of the same species that live in a particular area. Now, when we talk about an environment, typically we like to think of it as like a desert or whatever the case might be, but environment refers to both the physical environment as well as other organisms that live around them. Adaptations are any kind of traits that allow a greater fitness. In other words, a trait that allows a species or an individual of a species to survive better than those around them. And fitness is referring to the ability to survive and reproduce. So fitness is not like, who's strongest, but rather who is best suited for their environment in a way that they can make a bunch of babies. Okay. So Darwin's voyage is early 1840s. And during this time, he's collecting a ton of evidence and he's sitting on it because he realizes that essentially what his idea says directly contradicts what the church says. So he's very nervous about coming forward and saying, haha, I have my idea of natural selection, when he knows darn well that the church is going to have a little bit of a hissy fit. So finally, 1858, he met a man, Alfred Russel Wallace, and Wallace essentially came up with the exact same idea. And Wallace did not have nearly as much evidence as Darwin did, and Wallace really respected Darwin. So now that Darwin was kind of pushed to publish, he went ahead and he published the book On the Origin of Species by Natural Selection, and that was in 1859. So this lays out the framework of Darwin's ideas, as well as all the evidence, as well as the other scientists that were involved in helping him curate this idea. And so let's take a look at what that says. Basically, because we're thinking theory, right? Theory, we are thinking explanation. And so natural selection explained why all life was similar. And it's because they all arose from a similar ancestor. It explained the huge diversity of life because each species would be really well adapted to their particular environment, and it had a ton of time to evolve, right? So here we should be thinking Thomas Malthus. And evolution also explained why organisms seemed best fit for their environment, because those that had the best adaptations were the ones that survived. Okay, so you need 3 things for natural selection to occur. If you don't have these 3 things, natural selection will not occur. For starters, individuals must have variations that are inherited, so something that is passed from one generation to the next. So when you have a whole bunch of clones, they're not going to evolve because they're the same, and there's no natural selection to select on. Okay, easy. Some of those variations have to be beneficial for survival, whereas others are not so beneficial. So we're going to call those our adaptations. And then there has to be competition, so a struggle to exist, because you're going to have more babies born than can possibly survive. So those that have the best adaptations survive, pass those traits onto their offspring, and the species gradually changes over time. Okay, I want to take a second and look at some of the patterns of evolution. Actually, I don't. We're going to hold off for the evidence of evolution piece next week. So with that, hopefully that helped clarify the chapter, and I will see you on Monday.